Alright, so here is 8-8, solving radical equations. Again, this is nothing that should be very difficult. You just need to make sure that you're doing the steps. So what are the steps for solving this? Because that's basically what our objective is today. Well, the steps for solving this are, 1, we need to isolate the radical. If possible, we need to make sure that the radical is all alone on whatever side it may be on in the equation. And then second, we need to raise the both sides of the equation to whatever index or the power for that index of that equation to get rid of the radical. Then we need to simplify and solve, and those are just doing steps that you've done before. Okay, so I'm going to try to do quite a few examples with this one, and first example is going to be 2 square root of x plus 1 equals 14. So what we want to do here is we want to get rid of the 2. Since that's multiplying, we're going to divide. When we do that, we need to divide 14 by 2 also, and that leaves me with just the square root of x plus 1 is equal to 7. Then to get rid of the square root, we're going to square it. So 7 squared is 49. I've got x plus 1 equals 49. Subtract 1, and I've got x equal to 48. Now you should put that back in to double check to make sure that that solution is okay, which 48 plus 1 is 49. Square root of 49 is 7 times 2 is 14. So that does balance it out and does equal. So you should always double check your answers like that. Next example. 5. The cube root of 4x plus 3 equals 15. So divide 15 by 5. Get the cube root of 4x plus 3 is equal to 3. Then you're going to cube everything. So that means cube. Now notice all that does is get rid of the radical. And basically I'm taking that power to the number that's all by itself. 3 cubed is 27. So I'm going to have 4x plus 3 is equal to 27. Then I can subtract 3 to get 24, and then I can divide by 4 to get x equals 6. And again, if I double check this, I would have, let's see, 4 times 6 is 24, plus 3 is 27, cube root of that is 3, and then 3 times 5 is 15. So it does match. Okay, so in this example, you notice here I have square roots on both sides. But they are isolated. There's nothing, or they're as isolated as possible. I can't really do anything with that 5 because the square root of 35, it would just move it to the other side, which would be with another square root. So let me go ahead and square it right there. When I do that, that gets rid of the radical, and it gets rid of the x plus 2 radical, but the 5 will get squared. That will become 25. And notice how I'm putting the x plus 2 in parentheses. So then I distribute, I'd have 25x plus 50 is equal to 35x. Subtract the 25x, and I would get 10x is equal to 50. Divide by 10, and I get x is equal to 5. Now if you were to check that one, you're going to get, like on the right-hand side, 5 square root of 7. Well, then if you do 35 times 5, you get a number that, when simplified, would end up giving you 5 square root of 7. So they will match. Just not maybe in the way you would expect them to. Okay, in this next example, this is one where we really have to be careful of, and I'm going to try to do a couple of examples like this one. But I have the square root of x plus 18 is equal to x minus 2. Notice that the square root of x plus 18, or that square root one, is isolated. It's by itself. So I am technically ready to square this. So when I square this, I have x minus 2 squared. Okay, x plus 18. Now, x minus 2 squared, there is a shortcut to that where it would be x squared minus, and you would basically double whatever number is there. So doubling of 2 is 4, so minus 4x, and then square the negative 2, and that would give you positive 2. Then move your x over, move your 18 over, because we want everything on the same side as the x squared, because this is a quadratic function. You get x squared minus 5x minus 14. Do your parentheses, minus minus is plus minus, and it would be 2 and 7. And then the opposite of that would be x is equal to negative 2, x is equal to positive 7. Now, testing those out, if you were to put the negative 2 in place of the x, you would end up getting that positive 4 is equal to negative 4, which means that's not possible. So x equals negative 2 doesn't count. Doesn't work. It's an extraneous solution. Try that with the 7, and you get 7 plus 18 is 25, which is square root of 25 is 5. 7 minus 2 is 5, so that works. 5 equals 5. So you do need to double check, especially when it's two answers like that. Now, I'm not going to say that it will happen like that every time, but it may happen. Negative 9x, let's do it square root of negative 9x plus 28 equals negative x plus 4. Okay, so I square it, I get negative 9x plus 28. You square the next one, you've got x squared, 4 doubled is 8, negative 8, and then 4 squared is 16. Okay, so it's a very simple squaring process there. Move everything over, that's going to give you a positive x minus 12, which will give you x plus x minus 4 and 3. And that means x is equal to negative 4, x is equal to positive 3. Now, double checking those, they actually come out both. Okay, because if I put negative 4 in place of the x, I'll have negative 9 times negative 4 is positive 36. 36 plus 28 is 64. Square root of 64 is 8. And then put negative 4 on the other side. Negative of negative 4 would be 4 plus 4, which is 8. So 8 equals 8. So negative 4 works. Put the 3 in there and you get 27. 28 minus 27, which would be 1. Square root of 1 is 1. 4 minus 3 is 1. So 1 equals 1. So the 3 would work also. Okay, just a couple more examples here. In this example, I've got 3x minus 1 raised to the 1/5 power equals 2. Now remember that 1/5 means like saying the 5th root. But the real idea here is that all you need to do is go ahead and just think of it as a power. You know, and so what's the opposite of 1/5? 5. So if I'm going to raise that to the 5th, I'm going to raise that to the 5th. The 2 to the 5th. So that the 5 and the 1/5 would cancel each other out, leaving you just the 3x minus 1. 2 to the 5th power is 32, so I can add 1 to that, get 33, divide by 3, and I get x equals 11. Plug that in, you got 3 times 11 is 33, minus 1 is 32, the 5th root of that is 2. So there you go, it works out. Okay, so this last example, same thing, but notice that there is a 3 there with the x plus 6 to the 1/2 power. That's like if it had been 3 times the square root of x plus 6. So we need to isolate that first. So let's get rid of the 3, divide by 3, and we have x plus 6 to the 1/2 power is equal to 3. Well, then we can square that to get rid of it, and that would give me x plus 6 equals 9, subtract 6, and I got x equals 3. So you can see here most of these examples are fairly easy. There is some sections in this book that wants to go over radical inequalities. I'm not going to go over that, but you know, you can kind of see how this would work, and that's pretty much it. If you have any questions, feel free to ask.